In this tutorial, we're going to look at how to map out flood risks over time in the Boston Harbor area, specifically around Moakley Park. So previously, we calculated the probability or risk of minor, moderate, and major floods as they're defined by the National Weather Service for the Boston Harbor area. And so those floods are defined both in terms of the height of the water that requires to achieve that level of flood. So with a minor flood, that means that the water rises to 12.5 feet above mean low water, but also the probability of that flood. So when we look at the historic occurrences of that flood, we calculated that a minor flood, for example, has an 81% chance of happening in a given year based upon what's happened previously. Similarly, a moderate flood has an 8.6% chance, and a major flood has a 3.4% chance. So what we did in the Excel exercise is we looked at different scenarios for sea level rise of 1.2 by 2030, 2.4 feet by 2050, and 4.8 feet by 2070 to see how the chances of those same kinds of floods would shift over time. And not surprisingly, they become more likely as the sea level rises. So what we want to do is map this out, but we're going to take a slight twist on this. What we're going to be doing is we're going to be mapping out the area that's flooded by the current flood area, or the current flood risk, what areas are subject to that inundation if the water rises that high. And as we look forward to these future scenarios, what we'll do is we'll adjust the extent of that flooding, assuming that the water essentially raises the flood area by another, whatever that amount of water sea level rise that is. So if previously the minor flood meant the water would reach 12.5 feet, now we're actually going to raise it by 1.2 feet under the 2030 scenario, but we'll keep the probability the same. So what we're after, I'll show you an example, is this. So this is one of the scenarios looking at minor, moderate, and major flooding in the year 2050, assuming 2.4 feet of sea level rise. So the dark blue area, the minor flood, shows you areas that have an 81% chance of flooding in a given year. So essentially what that's showing you is that these areas have the same probability as a minor flood today, but the reach of the flood is further given the sea level rise. So what we want to do is then see what those minor, moderate, and major floods look like over time, holding those probabilities steady, as if they were kind of unchanged today, but just you get more area that's possibly flooding. So it's kind of a play on the same thing that we did with the Excel workbook. So this is just one of the scenarios. So what you'll be doing is generating the same or similar map for the current period, but also for the other scenarios that we looked at. So this is kind of one of the middle ones. So how do we do that? So the first thing we want to do is we're going to go into Arc Pro, and you'll need to log in if you haven't done so already the first time, and we're going to create a new map project. So every time you create a new map project, it's going to create a folder somewhere where you can store your products and your data. So I'm going to make sure I know where this is going. So I'm going to put mine into a very specific folder so that I can find the stuff again. So I'm going to put it in this folder here. Okay. And I'll choose that. That'll be the folder that I put it in. And then the name of the project will dictate what the actual project will be called, and we'll also create a folder with that name too, and everything kind of go into that folder. So I'm going to call mine flooding to keep it simple. And so when I hit OK, it's going to generate this new folder in that location that has it's going to contain most of the project products that I put, but I'm also going to save things in that location too. So just so we're clear, so when I open up my folder, so let me look at where that is. So let's see, I put mine, let's see, over here. And so this folder right here is one I created. I did this earlier, so you can see I was practicing. So in the flooding folder that I just created, automatically it's populated with certain items in there. And one of the things is going to be this geodatabase that we'll be using to store the output that we produce along the way. But I'm also going to save anything I download into this folder so that I don't it's all in one place, so I don't lose things. It's kind of good practice if you're working in Arc Pro. So what we're going to be doing is we're going to model flooding under different scenarios, and we're working specifically in Boston's Moakley Park area, so we can zoom in real quickly to see what we're talking about. So it automatically defaults to a nice base map, so we can kind of get a sense of where we're at. So I want to download a couple things to make this possible. One will be what's called a digital elevation model that will allow us to model the water reach, what reach of the water under different scenarios, and also a boundary polygon for the city of Boston that can kind of let us kind of clip to the area of interest. So I'll need to go to MassGIS for this. So MassGIS has most of the data sets that we need for our purposes here. So MassGIS has a free download free data section, and there's only two things that we need from there. One will be the administrative boundaries of the cities, the municipalities. So I'm going to jump to that. We want this municipalities layer, and so we'll choose the downloads, and specifically I would suggest downloading the geodatabase. It's slightly smaller than the shape files, and again what I would do is I would save that into your folder where you're keeping all the other stuff. So here I'm putting mine in that flooding folder that I created earlier. So it's a zipped file, so you'll need to, after you download it, you'll need to unzip it. So that's one thing. And then the other thing that we need is going to be the digital elevation models, which are what are called rasters, and they are treated like imagery. So if we scroll back up through here, we're going to get to an area called elevation. It's under the imagery section if we're coming from a table of contents, and we're specifically looking at the LiDAR terrain data. There's a DEM digital elevation model for the whole state, which you could just grab that and then clip that, but it's a big file. It's like 4 gigabytes, and it's actually lower resolution. It's better to go here because you can grab individual tiles that are higher resolution. So in there, we're going to scroll down a bit, and what we're looking for is a link to a utility that will help us identify the specific tiles that we need. So we want to go to the download DEMs from Mass Mapper, and that will let us grab individual tiles. So if I click on that and I enter there, and this one shows a grid that shows you where all the image tiles are, the elevation, digital elevation models. So we're going to zoom into the Moakley Park area specifically, and we're going to be downloading only the ones that are kind of around our area of interest. So you can kind of see there's Moakley Park right there. So I'm thinking what I'm going to do is I'm going to grab just all these tiles here. So the way that you do this is that if you click on an individual tile, you'll get a pop-up and it'll give you a link to directly download that DEM, which you could do one at a time. But just to make sure I grab all the correct ones, what I'm going to do is, instead of going one at a time, I'm going to use this polygon selection tool here. I click on it once, and then I'll click to draw like a boundary or a box of the things that I want to capture. So I'll click there, and I'll go, let's say out here, and down to here, here, and then you have to click on the last one to complete the box. And when you do that, it'll have a pop-up. It shows you what you encompass when you did that. So if you click on it, it'll show you the various links. You have to scroll down because there's quite a bit of them. So we want all of the ones that are in this column, the DEM column. So unfortunately, you have to click on them one at a time to download them. So you click on it like that, and then it'll prompt you to download it. So you'll download it into the same folder again. It'll be a zipped folder, so you need to download those and save them there. So that's the last thing we need. So we're going to download all those files, and then we're going to unzip them, and then we're going to bring them into ArcMap. So go ahead and do that one at a time. Might take a little bit. So once you've downloaded them, you should unzip those files. So you can see here I've unzipped them. So I've got zip files, and then I've got for the images, there's several files for each image. So you just want to keep track, make sure you got them all, which may be a bit of back and forth. In the case of the town survey item, when you unzip it, you end up with a geodatabase. So I think I neglected to do that. So that one, when we unzip that one. I'm using graphic. Okay. Oh, I see. That's why. Okay. All right. So I've unzipped them. The geodatabase unzip object creates both a folder, a GDB database, as well as accompanying files. For the most part, you're not interacting with, other than unzipping things, you're not interacting a lot here. What you're doing mainly is working in Arc Pro. So I've already downloaded my data. Back in Arc Pro, if I want to see the stuff I've downloaded, on the right-hand side, you may see this catalog window. And so under the folders window, you can expand that, and then you'll see flooding, or whatever you named it. So this is the name of your project will be reflected in this little object here, and that will be the folder where all your stuff is. So you should see a variety of these blue and white little raster symbolized things, plus a bunch of these town layers down here. And then in addition to, you see this town survey, which contains the municipal boundaries. So what we're working with mostly, this is the main thing, is going to be these images. So I'm going to highlight them all and drag them in. And so what you should see is that these will overlay this kind of black and white imagery that covers the target area of interest. So this is the main digital elevation model we're going to work from. And then the other thing that we want to have too is if you expand the town survey geodatabase, within that you're going to see another feature data set with these three little overlapping polygons. Open that one up, and then we want to bring in the town survey poly M, and that one has the municipal boundaries, so you can recognize the coastline of Boston when you bring that in. So we're going to use these things together to start processing our data.